e-commerce search logic requires highly structured product data. In the real estate sector, however, that data is trapped behind pixel-based image files. These photos provide visual inspiration to users, but lack the machine-readable metadata needed to drive a retail transaction. Relying on human agents to manually tag furniture across every listing photo creates an immediate operational bottleneck. It cannot scale. The solution requires a multimodal AI pipeline. The architecture must act as an automated bridging engine between the high-intent environment of a real estate platform and the active product inventory of a retail database. This graphic demonstrates the interface. The end goal of the system is to automatically map semantic hotspots, represented by these blue interactive dots, onto property images, and then route users directly to matching e-commerce products. This specific architecture connects two distinct modules. First is the Kemedar real estate platform, which acts as the traffic source. Second is the Kemetro marketplace, which serves as the retail conversion engine. To understand how this bridging engine operates, we will trace the system from the bottom up. We will look at the database schema, the AI vision orchestration, the responsive front-end state management, and the B2B monetization logic. The objective is to engineer a deterministic state machine that directly drives automated gross merchandise value. The pipeline is triggered asynchronously in the background. The exact moment a real estate agent publishes a new property gallery, the processing cycle begins. The system first interacts with the Analyzed Property Image database table. To strictly prevent redundant, costly AI processing, the system hashes the URL using SHA-256. This detects duplicates across the entire platform before any API requests are authorized. This core entity relationship diagram shows a parent record spawning a one-to-many relationship with image hotspot records. These store spatial coordinates as X% and Y% float values, rather than absolute pixels, plus a search keywords field optimized for full-text catalog searches. Finally, the table includes an is-shoppable Boolean flag. This flag requires a minimum of 2 identified hotspots to flip to true, establishing a strict quality control gate before the front end renders the UI. Structuring spatial data strictly as percentages at the database level guarantees the front-end UI remains perfectly positioned across all device viewports, completely eliminating the need for coordinate recalculation. Moving up to the AI orchestration layer, the queuing mechanism is tightly constrained. The batch process property images function limits analysis to a maximum of 5 images per property, prioritizing the featured and early gallery images to control API costs. The queue incorporates a hard rate-limiting safeguard, adding a 2-second delay between processing jobs to prevent upstream AI API throttling. Before any job fires, pre-processing guard clauses check the property's status ID. Expensive API calls are authorized only for properties explicitly marked as having complete finishing or high-lux interiors. Once cleared, the server downloads the image via the URL and encodes it into a base 64 string to prepare the payload for the vision model. This JSON payload caps Claude's output at 1,500 tokens, setting its persona as an interior design expert. It demands specific extractions, like room style and color hex codes, ignoring structural elements. Crucially, it generates optimized search keywords, like navy velvet tufted sofa, built for e-commerce matching. When the AI responds, the backend handling logic strips any markdown formatting, attempts to parse the strict JSON structure, and catches any syntax errors to prevent corrupted data from reaching the database. Precise prompt engineering, paired with rigorous schema validation, restrains the large language model and forces it to operate as a deterministic, reliable data extraction engine. On the front end, when a user clicks the Shop This Room toggle, the system applies a visual brightness filter to the image, dimming the background to render the hotspots clearly. This schematic details the CSS positioning logic. The UI takes the X% and Y% values from the database and applies a transform translate -50%, -50%, ensuring the interactive dot is dead centered on the coordinate, regardless of the container's aspect ratio. When a user clicks a hotspot, the front end fires the Search Kemetro Products function, passing the stored search keywords to execute a full-text search against the live e-commerce catalog. Look at the cross-platform shoppable UI details here. The resulting layout uses a responsive slide-out panel for desktop and a bottom sheet for mobile, displaying up to 4 matching products. This introduces a cross-module state management challenge, handling add-to-cart actions for users who are browsing real estate anonymously. Unauthenticated cart additions are stored in a temporary Shop the Look cart database table. These records are bound entirely to the browser's session ID, carrying a 7-day expiration time to live. If that user logs in or registers, the Merge Guest Cart function automatically triggers, porting the session-linked items directly into their persistent primary Kemetro user ID cart. This asynchronous state management strategy captures high-intent impulse actions immediately, removing the friction of upfront user authentication. The ultimate commercial value of this architecture lies in its ability to algorithmically generate net new, highly contextual digital ad inventory. Through the B2B seller panel, e-commerce vendors on Kemetro can filter high-traffic real estate properties and programmatically bid to sponsor specific AI-identified hotspots. This alters the database state. The image hotspot record toggles its is-sponsored flag to true, linking the vendor's specific sponsored product ID and recording their daily budget. Focusing on the monetization and performance section, you can see the front-end injection logic. When the search query fires, the backend ensures the sponsored product is forcefully pinned at index 0 of the results array, bypassing organic search relevance. The hotspot sponsorship log records every event. Visual impressions remain free, but sellers are billed against their budget strictly on a per-click basis. What begins as a passive image upload is algorithmically structured, mapped to a responsive UI, state-managed across domains, and fully monetized via a programmatic ad loop, entirely without human intervention.